Hello guys, this is prime concept. So we're still considering the concept of complex number. In this video we'll still go further to look at some more algebras of complex number. In our previous video we introduced complex number. We looked at algebra, the various operations that are carried out in complex number. We talked about addition of complex, we talked about equalities first, then we considered addition and subtraction of complex number. In this video, we want to look at multiplication of complex number as an algebra. Multiplication of complex number. How do we multiply complex numbers? It's very simple. So we're going to see how to multiply. So I'm going to use a simple idea in multiplication here. I'll be distributing one over the other, and then we can see how to do that. But before that, I want to quickly help us understand this. I want you to note this as it will be helping us. Note that in complex number, we said that I actually represents the square root of -1. This is what we said, right? And I want you to know that if I is the square root of -1, it would also mean that I squared will actually be me squaring both sides. Abi? Yes. So meaning that I squared would give me -1. So don't forget that since I is the square root of -1, I squared should be -1. I'll be using this idea in my multiplication very well. Now, very quickly, we're going to go straight to an example in multiplying. Now, let's say we have a complex number z1, and z1 is x1 plus I y1. We have z2, which is x2 plus I y2. So if I want to find z1 times z2, what I simply need to do is to distribute x over this. So what I have here is, okay, let me write it. This is x1 plus I y1 is multiplying x2 plus I y2. This is what I have. So an easy way to multiply this is to distribute. So I would say x1 would distribute over x2 plus I y2. Same way, I would say plus I y1 would distribute over x2 plus I y2. So this is what I'm going to do. So I'm going to use an example to make you understand this. So let's take this example. z1 is equal to 2 plus 4i. z2 is equal to 3 minus 2i. So I want to find z1 times z2. I want to find this. So what I'm going to simply do is to use 2 to distribute over this. So follow what I'm doing so that you really get it. I'm using this. So I'll say 2 distributing over 3 minus 2i. Then same way I would say plus 4i. Plus 4i would distribute over the same thing, 3 minus 2i. This is just what the multiplication would mean. So let's do it together. 2 times 3 would give me what? 6. 2 times minus 2 would give me what? Minus 4. Then I'll have my I. Right? Then I'll come to this part. 4i times 3 is going to give me plus 12i. Right? Now let's do this other part carefully. Plus times minus, what will it give me? It will give me minus, right? Plus 4 times minus 2 would actually give me minus 8. Remember, I didn't touch the I. So I'll quickly say I times I is actually I squared. So let me repeat that part, the last part. I said plus 4 times minus 2 gives me minus 8. Then I times I is actually I squared. I've not evaluated that yet. So that I have 6, which is a real part. Then this is minus 4i. This is plus 12i, imaginary parts. I can add them. So what it means is minus 4i plus 12 is going to give me plus 8i. Then on this other side, remember I squared, we agreed. I squared is actually minus 1. So minus 1 times minus 8 would now give me what? Plus 8. I re-explain. I squared would give me minus 1. Minus 1 times minus 8 gives me plus 8. So that if I add this, I'll then have that z1 times z2 is going to give me 6 plus 8, which is real part, which is actually going to give me 14, right? 14, then plus 8i. So this is what I have in the multiplication of the two complex number. I'll take one more example to make it even clearer to us. Now, very quickly, let me rub this part. Okay, let me start from here. Now, say we have this complex number. We have z1 equals, let's say, 3 minus 2i, and we have z2 equals 1 minus I. Say we have these two, and we want to find z1 times z2. So we want to find this. I'll do the same thing. So I have that z1 times z2. This is going to be, I'm going to distribute 3. So I'll say 3 into 1 minus I. Then I'll say this part minus 2i into 1 minus I. So I'm going to distribute this way. Now very quickly, watch what I'm doing. 3 times 1 would give me 3. 3 times minus I would give me minus 3i. I'm done with this first part. So watch this part carefully. Minus 2i times 1. Minus 2i times 1 is what? Minus what? 2i. Carefully again. Minus 2 times minus 1, because the coefficient of I in this case is actually minus 1. So let's multiply the coefficients first. Minus 2 times minus 1 is plus 2. Then I times I is I squared. So I'll go gradually. 3. Then minus 3i minus 2i will give me minus what? 5i, right? Yes. So that if I look at this, this is I squared. So I squared, what will I squared give me? I squared would give me negative 1. Negative 1 times plus 2 will give me negative 2. So I have negative 2 here. So that I can finally say 3 minus 2 is what? Is 1, then minus 5i. So this is z1 times z2. So this is what I have as the multiplication of this. Abi? So very quickly, I want to point out maybe two properties for multiplication, and we call it an end for this video. So properties. Number one property is commutative property. Just like we saw for addition, commutative property for multiplication is also true. Commutative property. That is to say, z1 times z2 will give us same result as z2 times z1. So this is what we know as commutative property for multiplication, which is true. Another property I want to point out is associative. So if I have z1 times z2 times z3, this is same thing as z1 times z2 times z3. So this is also true. This associative what? Property. So I want to just point out these two properties. We have more, but let's just stick to this. Associative properties. So we should know these properties, right? Yes. So this is true. So we're going to call it an end for this video at this point. We're going to call it an end, but let me just add, say, 2 more properties, just like we did for addition. If I have a complex number multiplied by an identity 1, this would always give us the same complex number, just like we know for real numbers. Whenever you multiply any real number by 1, it gives you the same real number. So you multiply a complex number by the identity 1, it gives you back the same complex number. And you should also know as number 4 property that when you multiply a complex number by the inverse of that complex number, this would actually give us what? 1. It would equate 1. So these properties and more are true for the complex number. So I believe at this point the concept of multiplication is really very clear to you. If you have understood what I've done, I would like you to drop the answer to z1 equals 2i, z2 equals I minus 1. Now I want you to find z1 times z2. z1 is equal to 2i and z2 is I minus 1. So drop the answer in the comment section for z1 times z2. So drop the answer and I'll check it and check if it is correct. Thanks for watching this video. You are yet to subscribe, quickly hit the subscribe button, drop your comments, like the video, share with your friends, tell them it is prime concept. In my next video, I'll be doing something very important, which is known as conjugate of complex number, which is very important for us to learn division of complex number. Thanks for watching Prime Concepts.